Good morning. So you are watching the video for 2.1, the power rule, uh, the derivative power rule. So instead of my other videos, which were a little longer, is what I've been told, I decided to fill out the note ahead of time, okay? And then I'm just going to go through it. If you have any further questions and you want me to break it down further, I can. Okay, so we'll start with the power rule. So now that we are done with the first principles, okay? Some of you have even noticed that, hey, there's a pattern for some of this stuff. Okay? Um, when we were working through the first principles, some of you noticed, in fact, if I were to scroll down here, some of you noticed, if I were to use the first principles on something like that, okay, we got 5x4. And then you thought, hey, I wonder if there is a power rule, or if there's some kind of rule to that, or if that's just a coincidence. Well, it's not a coincidence. It is the very first derivative rule that we're going to talk about. Okay, so there are a lot of patterns. There's a power rule, there's a product rule, there's a quotient rule, but we'll get to that. So we'll start with the power rule. Okay. In fact, before we talk about the power rule, let's talk about the. Sorry, I'm just plugging in my writing pad here. Derivative of a constant. So what is a constant? A constant is just a number. Okay. So what's the derivative of any number? So for example, fx equals 6. So logically, let's think about what that line even looks like. Fx equals 6 is the same thing as saying y equals 6. So really, it's just a horizontal line at 6. So if I were to ask you the derivative of that line, what I'm asking you is the slope of the tangent of that line. Well, try to picture drawing a tangent. Like, for example, if I drew a parabola and I ask you to draw me the tangent at x equals to 3, most of you would be able to do that and go, oh, there's the line, or there's the dot at 3, sorry. So this must be the line of the tangent. But if I asked you to draw the line of the tangent at 3, isn't it just a line that pretty much overlaps the line that's already there? So remembering that the derivative is just the slope of the tangent, then what's the slope of that tangent? Well, what's the slope of the floor? What's the slope of any flat surface? It's 0. Okay, so the derivative of any constant is just going to be 0. Okay, and you can prove it, and we just proved it with a quick little diagram here. We can also prove it with um, first principles. So what's fx plus h if fx is equal to a number? So let's say 6. Well, if I replace x with x plus h, does that change anything? No, it's still going to be 6 because there's no x to replace with x plus h. So here we end up having just 6 minus 6. Or in this case, because we're using the general case of any number c, then we end up with just c minus c. Well, c minus c is 0. 0 divided by anything is 0. So then the limit is just 0. Okay, so in other words, the constant of any derivative, sorry, the derivative of any constant is 0. Now, derivative of power. So what we could do is I can take that and prove it to you using the first principles. So if fx, which I'm not going to do, don't worry. I'm sure you can YouTube it and it will show up. But if I were to ask you for the derivative, I'm asking for this. Limit as h approaches 0, okay, of x plus hn minus xn over h. Yeah, so I am again looking using the first principles, and I will find that it equals to that. So what does that mean? So to find the derivative using the power rule, okay, all you do is you bring down the exponent, bring down the exponent to the front, and then the exponent itself, subtract 1. Okay, so here are a couple of examples. The 5 got brought down, that's where we got the 5 from, and then in the exponent we have 5 minus 1 gives me 4. That's the derivative. And again, if you're not convinced that's true, you can use the first principles and go limit as h approaches 0 of x plus h to the exponent 5 minus x to the exponent 5 over h. Solve that and you will get 5x4. Okay, so same thing here, brought the 7 down, 7 minus 1 is 6. Done. So yes, Some of you did try to do this in the last week when we were working with first principles. You cannot, okay? Not in the first unit. Now we can, now that we're in the second unit. Because that first unit is very foundational stuff. As in, we need to know what the point of all this is. If I just gave you the derivative rules, that's great. So what, right? So it's linking it to the definition of a derivative, which uses limits, and finding the slope of a tangent, which is the instantaneous rate of change. They're all connected. So if in that first unit, as soon as I see derivatives, it's usually a red flag for me, unless it is you were taught that through a tutor. I can't help but think that there is probably some kind of technology being used. So in that first unit, make sure, or I guess we're past that now, but I was looking to see who was using the first principles versus just finding the derivative. Because if I type this into any program and ask for the derivative, it will give me this. It will not give me first principles. Okay, so for C, to find the derivative, again, move the -4 to the front. What's -4 minus 1? -5. And then when dealing with negative exponents, this has to be brought under because it has a negative exponent and it becomes positive. Okay, and then these are pretty much the same thing. This is just a proof of why that works, again using first principles. But if I wanted to find the derivative of something like that, same thing, and move the 6 down. But since there's already a 5 there, well, what's 6 times 5? 30. Okay, and then the exponent, I take away 1 from that. 6 minus 1 is 5. Same thing here, brought the 3 down. 3 times 7 is 21. 3 subtract 1 is 2. Okay. Well, what happens when we have multiple terms? The same thing applies. So the 12 goes down. 12 minus 1 is 11. The 8 goes down. 8 times 4 is 32. Ooh, I actually made a mistake here. There should be a 7. Whoops. I'm got to make sure I correct that in the answer sheet. Yeah, there should be a 7 there. Why? Because 8 minus 1 is 7. And then 4 times 7 is 28. 4 subtract 1 is 3. And what's the derivative of a constant? It is 0. But I don't need to put a plus 0 there. But that should show you the derivative of 22 is just 0. Okay? Same thing for B. Determine the equation for the tangent line to the curve of that. Okay, so it's asking you to, so I don't know what this graph looks like. Okay, I'm just going to draw a random sketch. I do know it's cubic, so it's going to look, I don't know, something like that. Okay, tangent line to the curve at x equals to -1. So it's asking at x equals -1, what is the equation of that line? The tangent line. So in other words, what's the equation of that line? Okay, obviously that's not an accurate drawing, but that's what the question's asking for. So I need to end up with an mx plus b, which is the equation of any given line. Well, then I ask myself, how do I find the slope first? How do you find the slope of a tangent line? Wait, that's the instantaneous rate of change. Wait, isn't that just the definition of a derivative? It is. So I find the derivative. Okay, so 3 times 4 is 12. 3 times 2 is 6. Okay, and then the exponent, 2 subtract 1 is 1. 3 subtract 1 is 2. So this is the derivative of that function. So if I want to find the slope of that tangent line, I just sub in x equals to -1. Okay. Uh-oh, this looks like a positive 1. That should be -1. So if I sub in -1, well, let's double check if this is right then. This might be wrong. So if I sub in -1, I will have f prime of -1 is equal to 12 times -1 squared plus 6 times -1, which will give me -1 squared is 1, so 12 subtract 6, which will equal to 6. Okay, so this was right. I just forgot to put the negative there, which tells me that the slope of this tangent is 6. So then that's the only thing I know. So how do I find B? Well, I just got to plug in a point. Well, what point do I plug in? Well, I am told to find the slope of the tangent at x equals to -1, right? So how am I going to find the y value? Well, just sub it into the original equation, and when I sub in -1 for x, I will get 4, which means this coordinate is this coordinate. Okay, so to find the equation of the red line, just sub it in. X is -1, y is 4, solve for b. That's my equation. Okay. Oh, one more. Whoops. Determine the points on the graph of where the slope of the tangent is 24. So, again, this graph I'm about to draw is not accurate. This is just to give you a visual. So let's say it's some cubic function, because it is cubic, with the slope of the tangent 24. So let's pretend the slope of the tangent is 24. So if I wanted to find, let's pretend this line I just drew has a slope of 24. Whether that's true or not, I don't know. But I want to find on this graph where, at what points will I have a slope of a tangent of 24. So if I copy and pasted this line, it might be right here, and it also might be right here as well. Okay, so I could have two potential answers. How do I find those 2 points? Well, I see slope of the tangent, so I should immediately find the derivative, which I will. Move the 3 down, 3 subtract 1 is 2. Move the 2 down, 2 times 3 is 6. 2 subtract 1 is 1. That is my derivative. Okay, so now slope of the tangent is 24, which is another way of saying the derivative is 24. So I set 24 equals to the derivative, 3x squared plus 6x. And then from here, I just simplify. So what I did was divide everything by 3. 24 divided by 3 is 8. The 3's are gone. 6 divided by 3 is 2. Move the 8 over, factor it to get x plus 4 and x minus 2. Oh wow, this might be pretty spot on with my rough sketch. So x is positive 4. Okay, so which means at x equals to -4, -4 would be where the slope of the tangent is 24. And also when x is positive 2. Positive 2 is where slope of the tangent is 24. And how did I find these values? Because it does ask me to determine the points. I just subbed in -4 and 2 into the original equation to get -16 and 20. Obviously this is not -16, right? Again, this sketch is not accurate. It's just to give you a visual to make sense of what they're asking you to find. Okay. Any questions? Shoot me an email. Hopefully that was a little better than slowly going through each question. Okay. We'll talk soon. Bye-bye now.